Hello and welcome to Dr. T's Math. In this video I'm going to cover a topic that I covered a couple years ago in person. During the lockdown I made several videos in a classroom in Eastern Saudi Arabia, and somebody recently told me that the video is both of poor quality and the sound is inaudible, and so maybe I'll go through some of those old videos in a new series here. In this one, imagine we have political affiliation on one axis and some issue on another. Should be an S. And we've got three political parties, A, B, and C. And the basic rundown is that roughly 37% of the population associates or identifies as Party A, or Party A leading. 29% of the population associates with or affiliates with or identifies with Party B, and 34% identifies with Party C. Those sum up to 100% of the population. And then on an issue, we've got for the issue plus or against the issue minus. 51% of the entire population is for, 49% is against. Imagine if Party A dominated the political spectrum, then this issue would probably not pass if Party A alone were to vote on it. Probability of Party A, probability of a randomly selected person being affiliated with Party A, that's P of A over here on the right, is 37 over 100. 37 over 100. It's always part over a whole for probability. Probability of B, political affiliation, is 29 over 100, and probability of C, again, this is given our data, we would expect a randomly selected person in the population to have roughly a 34% chance of being affiliated with Party C, or that could be no party affiliation or no preference or independent. Probability of a randomly selected person from the population being in favor of the policy is 51 out of 100, 51%. Probabilities will always be between 0 and 1, where 1 is 100%. And then the probability of a randomly selected person from the population not liking the issue is 49 out of 100. So you can see here, if it's a hotly contested issue, and who's to say if the people in the majority are right or wrong, but if it's a hotly contested issue that could be decided by, for example, a ballot measure, in this case it would pass because 51% of the population would vote for that policy, whereas 49 would vote against. So that ballot measure would pass. But depending on the balance in Congress of all the three different party affiliations, whether it passes or not may depend on the proportion of people in each party who would vote for it against it. So let's look at some conditional probabilities, like probability that somebody is for the issue or for the policy proposal given that they're in Party A. That's going to be 12 who are for it in Party A out of a total of 37 in Party A. And then probability of being for it given B. So then our given is the total population, that's 29, and the total who are for it is 24. The probability of being for it given Party C likewise follows the same pattern. 14 out of 34 are for it in that party. And then it's just the opposite. If we want to say probability of there being negative given that they're in Party A, that's 25 out of 37 in Party A. And then in Party B, it was 4 out of 29. Party C, it was 20 out of 34. And then looking at it from the opposite direction, the probability of somebody being in Party A given that they are for it. So now our total population, our total to take into consideration is those who are for it, which is 51. That'll be our bottom number, 51. And of those, only 12 are from A. And then with B, same pattern, same process, 25 out of 51. And then for C, 14 out of 51. And finally, probability of being from party A given that the issue is opposed, 25 out of, now our total opposing is 49, so we're 25 out of 49. And then 4 out of 49 and 20 out of 49. Looking at these numbers, we can infer a couple different things about which parties are more or less in lockstep with the average person. And you can see that on this issue anyway, it's going to vary issue to issue for certain. But on this issue, only 12 of 51, or sorry, only 12 of 37 in Party A are for that issue compared to a total of 51 out of 100. So then Party A is not for that issue about, it should be roughly 19 or 18 out of 37, 18 or 19 if it wants to be proportionally representing the entire population. So legislation, well, this is going to depend. Ballot measure would pass on this issue, but legislation depends on party. Which party is represented more in Congress? In the United States, for example, we have only 2 parties to speak of, and so that changes the situation a little bit. On the left, imagine this is the Congress, and on the right, it's in the general population. And the views in Congress may or may not reflect the views in the general population, depending on the issue. On some issues, hot button issues, or like some people are one-issue voters. Maybe on those issues, the views of the political party may be in lockstep with the views of individuals who identify with that party. But on a range of other issues, there's probably some crossover between individuals, or there's some maybe lower levels of allegiance to party than you may see in Congress, depending on the issue, of course. So in this issue, it looks like in Congress we got 51 to 49, so it would pass the legislation. But in a ballot measure, the pluses, plus minus, in this case, ballot measure, it would not pass. Let's have a little deeper look at that. So Party A, you got 49 for and 2 against, for a total of 51, and that's coincidentally the number it took to pass this measure, whatever it is. But they required 2 from Party B. Without those 2, it would have failed. So this is mildly bipartisan. It would pass for bipartisan in today's world, but it's basically on partisan lines and party lines. Compared to, let's look at the population. Looks like 36 to 1 people in Party A favor this thing, which is roughly proportional to what you see in Congress. But the main difference here is, so Party A controls just over half of whatever seats in Congress, if this is the House, or if it's unicameral in a different country, or bicameral. 51 to 49, so Party A has a slight majority in the legislature, but in the population, people more commonly identify with Party B. So this could be a situation where Party B ran some very unattractive candidates, or it could be through gerrymandering or some sort of voter suppression that this type of situation may resolve. But you see that a ballot measure, a thing that would be very popular in the population, would not pass maybe in a situation like this. And the example given here is that a ballot measure passed in the government, but it was actually not representative of the majority of the population. And it's also quite possible that beyond the party affiliation or representation or proportionality of people identifying with parties in the population versus in Congress, it could just be the issue. Like a small minority of people in this party may prefer this issue, whereas in the population, people may not like that issue. For example, billionaires or very wealthy people or employers or multinationals may be for some issue, and then the Congress may pass an act in favor of that issue, but maybe in the population it would fail, right? It would fail. All right, so this has been Dr. T's Math. Thanks for paying attention. Bye.